Hey guys, so we're moving on to question 8, and this is the second time I'm doing it, but hopefully my explanations will be better this time. So this question is really good in the sense that it really does highlight a lot of key parts of knowledge within the paper 1 syllabus. So it looks at functions, it looks at factorization, it looks at the quadratic formula, and it looks at interpretations of each of those, right? These are all very key sort of nuances of the syllabus. So let's firstly look at the first question. So it says, explain why the equation 2x minus 1 all squared equals -5 does not have any real solutions. Now, what's important, right? Whenever we square something, we generally get a positive, right? If it is a real solution. So -2 is real, right? If I square it, it's 4. 2 is real. If I square it, I get 4. So it's always positive, right? So it always has to be greater than 0, whereas -5 is less than 0, right? So we know that it isn't a real solution, or we wouldn't get a real solution here if we wanted to equal -5, okay? So the only things that equal a negative when we square them are imaginary numbers, right? So like the square root of -1. When I square it, gives me -1. But the square root of -1 is an imaginary number. It's not a real number, okay? And that is why you just write this for the answer. We would just say, well, if you square it and you want a real solution, it has to be greater than 0, the answer. It can't be -5, okay? If you want to get -5, it would have to be imaginary. And we can't have that in this sense because of the restriction. Okay, so it's just testing whether you understand the nature of a square and when a square can be a negative, when it can't be a negative. And it's important to understand the words and the classifications of different numbers. Okay, so then it says, on the same set of axes, the graph of y equals 2x minus 1 all squared plus 5, right? It says sketch. I think I forgot to say that. So that's the action that we need to do. And it says, show the coordinates of the turning point and the y-intercept. When you see the words y-intercept, right, you should always be thinking where x equals 0, right? Here we know that this is a parabola because it's squared, and it's of this form, right? And we know that it is a positive parabola because there's no negative in front of the bracket here. So we know that we're looking at a parabola like this, and we want to get the turning point. Now, importantly, we know that when we have a parabola in the form like this, we know that P and Q are our turning point, right? Q is our shift vertically, and P is our shift horizontally, okay? And we just put that in. So instead of just putting P, because in this case you would be like, oh, okay, it's just 1. But it's not 1, right? It has to be x minus P equals 0. So the turning point is at x equals P. So here we know that the y coordinates of the turning point is just 5. We can just read it off there, right? Simple. But we have to make that whole inside of the bracket equal to 0 to get our turning point. Okay, that's a little bit tricky because sometimes we forget to look at the coefficient of x here. Okay, so we equal it to 0, we get what 0 is, and we can basically read off our turning point. Okay, so it's important. What they're doing here is they're testing your understanding of the various representations of a parabola, okay, or of a quadratic, depending on, both those words mean the same thing. Then, here, it says y-intercept, right? We have x equals 0. So I literally just substituted 0 wherever x was in the equation. Solved, and I got y equals 6. Okay, so we know that we now have 2 points. The turning point, okay, and the y-intercept. Remember the y-intercept, you get one answer here, but it's where x equals 0. So remember, it gives us another point on the graph. So we have 2 points. We know that it has to look like this because it's a positive parabola, so we can sketch it down. Okay, so I've plotted my 2 points, right? So here, between 0 and 1 is half, and each of these lines here represents 2. So that's where 5 is. That's my turning point. And then we know that my y-intercept, where x equals 0, is over here. We know it's that form. Draw in that form, and we are done. Okay, don't spend copious amounts of time plotting different points. They just want the general shape and they want the 2 key points that they asked for. Okay, it's only for 3 marks. Don't be spending like a good 10 minutes plotting different points. Waste of time. You won't get marks for that. Rather just do what you're asked. Okay. Then it says here, describe how you would shift the graph vertically so the x-intercepts are real and equal. Now, we see at this point there are no x-intercepts, right? Because it's all sitting above the x-axis. So if we brought it down 5 units, then the turning point would be sitting on the x-axis, right? And then there would only be one x-intercept. I mean, one one x-intercept. Sorry, I'm getting confused between my intercepts, yeah? There would only be one x-intercept over here, which would be 1 over 2 and 0. Okay, sorry for the noise in the background. I'm not sure what's going on. All right, so it would be sitting there. You'd have one intercept. And I would wager that that's the best thing to do. You might want to shift it down more so that you have 2 x-intercepts. But the problem is they wouldn't be equal, right? And what does the question ask? It says real and equal. So if it was just real, you could shift it down 6 units if you want, and then you'd have to shift it left. Well, you wouldn't actually have to shift it left either. You just have to shift it down, right? And you could get 2 x-intercepts, and that'd be fine. But here, because it said equal, you only really want one intercept, right? Which would be this one that I've showed you here. If you shifted it down more, you would get 2 x-intercepts, but they wouldn't be equal. So you wouldn't meet the condition. Okay, so it's important to read the question because you might misinterpret it even though you actually understand what is being asked in the sense that they're asking you for a shift vertically. Okay, so it's just important to understand that nuance. It is only 1 mark, but you don't want to be losing marks where you can get marks. Okay. Now, let's go to question 4. So, it says, solve for x in terms of k if 2x minus 1 all squared equals k. And write down the value of k for which the equation has real roots. Remember, when we want real roots, we're saying, oh, we want to be non-imaginary. Okay, so what I did is I said, okay, well, when I want to get roots, I actually want to factorize. So let me actually multiply this out. So you see I multiplied it out, made it equal to k, multiplied it out, and got it in this form here. I put this in brackets to remind myself that I can leverage the quadratic equation. Because you see here, a equals 4, b equals minus 4, and c equals 1 minus k. Then what I did is I said, okay, well, I know that if I want to get the roots of something, I can use the quadratic equation. So I just substituted each of those into my quadratic equation, which is given on the formula sheet I just showed you. Okay, and I solved through, right? So it's literally substitution. Make sure you multiply out correctly, and this is the answer you get, right? You get 4 plus minus. Don't forget the plus minus. I have this habit of just putting plus. Don't do that, right? Just to highlight here, right? This is actually negative 4, right? And that's why that becomes positive 4 over here, because we see that b is negative, right? Just to make sure you're understanding what I'm substituting in. You simplify. You can simplify further, right, by taking out this 16 and dividing through by 4. But that's not super important. You won't lose a mark for not simplifying completely. What you will lose a mark for is if you don't say the parameters of k. Because it says the values, write down the values of k for which the equation has real roots, right? That basically means that this square root here cannot equal a negative, because then we get a square root of a negative, which we've just highlighted is an imaginary number. So it's important to put in that k has to be greater than or equal to 0. It cannot be less than 0, okay? Because then we are imaginary. We're in the imaginary realm, okay? It could equal 0, right? Because if we put a 0 in here, oh, sorry, my dogs are doing the most amount of barking. I hope you can follow me. Okay, if we put a 0 there, right, then you just get, okay, 4 over 8. That's still real. It's fine. It can still be 0. It just can't be less than 0. That's important. Now, let's go on to the next question, which I originally messed up in my previous video, and that's why I'm redoing it now. Okay, so it says, give 3 values of k for which the x-intercept of y equal to 2x minus 1 plus k, will be real, rational, and unequal. Okay, that is so important. They're giving you restrictions. Don't let those things go out of your mind. Remember, that must be your forefront because it's a restriction. Now, the mistake I made over here was that I just thought this equation was exactly the same as the equation I had up there. But over here, right, k was on that side. So when I brought that to the other side, it was negative k. But here, when they're all on the same side, it's positive k, right? So my quadratic formula is going to look a little bit different, okay? So when it would basically be 4x squared minus 4x plus 1 plus k. Do you see that, right? It is now a plus, not a minus. It's very tricky, this, because they give you this like false sense of security. You're like, oh, no, what's going on? And then, bam, they change the sign. Okay, so it's very important to follow, okay, and to not project what you think the question is, but rather to read the question, okay, because you can see my projection didn't do so well over here, okay? So we've written out this, no problem. Let's put it into the quadratic equation. So the quadratic equation, exactly the same as we did before. Right, sorry, make sure I put my square root in there. So it's minus 4, 4, 1. Oh, got a little bit lyrical there. Okay, but it's plus 1, not minus 1, over 2, 4. Now, this here is what we want to apply the real, rational, and unequal to. Okay, but we know that these here, I mean, that equals, let's just put it here, that equals 4 plus minus, it's going to be 16, minus 16 plus 16k. Is that right? No, sorry, that's going to be negative 16k because that negative comes in, over 8, right, which is 4 plus minus negative 16k over 8. So now we have to find 3 values of k for which the x-intercepts, right, so basically the solutions, the roots, the zeros, all same words for the same thing, will be, or different words for the same thing, will be real, rational, and unequal. Now, right, we are then actually only interested in this negative 16k. Because if that, and we call that, we call it the change. There's actually a specific word for it, but I can't remember it offhand. So this negative 16k, that is all we're actually interested in. We have to make sure that this is positive, right? It has to be positive, okay? Has to be positive. So let's think about what it could be. So I'm just going to go and rewrite that whole bracket over here. Let me just use not a calculator, a highlighter, just to show you that technically that change equals this whole little bracket. That whole, so it's basically actually, let me just write it out in terms of b's and a's. It's the b squared minus 4ac. Okay, so that's what it equals. So we're wanting this, right, to have, it has to be positive. So this whole thing has to be positive, right? It has to be positive. That has to be positive. So we know that we have a negative here. So we know that the roots that we're going to propose, let me just make sure. The roots we're going to propose are all going to be negative, okay? So it could be, so k could be negative 1. K could be negative 1 over 4. Okay, and remember now, because there's actually, we so focused on the real that we're forgetting about the rational, right? So what I'm trying to do, right, is I'm trying to get it in a form that is rational so that we're not getting, because remember, if we have like square root of 3, right? If we have, I think it's square root of 3, it can't be written in terms of a fraction. And remember, that's what rational means. It means it can be written like this in terms of a fraction. So you don't want to just put any arbitrary number. So you want to put like 2 and whatever. You want to put it in a form so that you know that that square root, right, is going to make the overall solution real, rational, and unequal. So we know if we put negative 1 in there, right, that becomes 16. And then we know that root is going to be 4, right? And then it's going to be 4 plus minus 4 over 8. So we know that that is real, rational, and okay, at this stage, unequal doesn't matter because we only have one solution that we're proposing, right? It's real and rational, it meets our criteria. Then here, the reason I'm saying k equals negative 1 over 4 is because, right, if I put that in there, all right, it's then going to be the square root of 4. So then it's going to be 4 plus minus 2 over 8. And we know that that is real, rational, and unequal now to negative 1, right? Okay, and that's why I'm trying to make sure that I am sticking to my roots that I know, my perfect roots, right? Like this, right? Because we have 1, 4, 9, 16. So I'm trying to either focus on that one, or that one, or that one. Okay, so that's what I'm trying to do. So I'm thinking that maybe our last solution, we could do negative 1 over 16, because if I put that in, right, that's just going to give me the root of 1. And the root of 1 is just 1, right? So then we have 4 plus minus 1 over 8. It's real, rational, and unequal to these other ones. Okay, so it's very important to bear those restrictions in mind. You can't just put any number, okay? Because then you could get real, irrational, and unequal, but then you haven't met the criteria. Okay, so this is quite a tricky question because you have to bear all of those different things in mind. So here, right, the positive helps us with the real part. But then here you have to almost troubleshoot, right, to get something that's rational. Remember, rational can be written in terms of a fraction, okay? If you put 3 in, right, if you solve for this and it became the square root of 3, as I said, then it's not rational. So it's very important to understand your classification of numbers. If you're like, Margie, I don't understand what you are saying, go back and revise all your different classifications of numbers. Go whole numbers, natural numbers, integers, rational, irrational, real, imaginary. I want you to go over those because it's testing whether you understand that. Okay, very important. Okay. So I hope that's helpful to you, right? This is not the only way to do it. You can go to the memo in the link in the bio, right? And it will give you an alternative way of doing it. But I wanted you to be aware of this way of doing it and why these are the specific values of k that they propose as opposed to other values that you could have. I mean, there are a lot of values you could put there. These are just the easiest ones to get. But I wanted you to understand why you can't just put any arbitrary number because we have rational as well as a criteria. Okay. So let's now move on to the last question of this question. And I'm sure by now you agree with me that this has been a tricky little question, right? But this is only getting more tricky. But worry not, we will do it. Okay. So it says, let the larger root, right? And larger means, right, that it should be the biggest, okay? Not rocket science, that. But remember, when we have quadratics, we're going to have 2 solutions of x. So we're going to have to choose one of those solutions which is larger, okay? Of this quadratic be p, and let the larger root of this quadratic be q. And then it says determine the ratio of p to q. Now you might be like, okay, I'll just skip this question and go to the next one. No, we do not skip. We persevere. Okay, so let's figure out what we would do. First and foremost, let's just use the quadratic formula to get the roots for each of these, right? It's not, I mean, that's the first basic thing we can do, and then we can look about the ratio. Let's just first find the actual roots, right? Because we can't find the larger root if we haven't found a root at all, right? So we're going to start with this px squared plus qx plus r equals 0. So let's find the quadratic. So you can put this above just to help you, right? So we have negative b, so it's going to be negative q plus minus q squared minus 4p and then r, okay? Right, so I'm just literally subbing this into this quadratic formula. I hope you're following me. If you're not, write this down and substitute it the same way I am, and you should get the same answer as me. Okay, so now we see that this is negative, right? So what is the largest root going to be? Well, it's going to be the positive version of this, right? It's going to be positive q squared minus 4pr over 2p. Okay, because if you did the negative version, well, then you'd just be getting smaller, right? You're getting smaller than q, but we want to get bigger than q. The largest root is that one. Now, let's do exactly the same thing for this second quadratic that they've given us, right? And don't panic. It's always important with these questions because sometimes you start doing it and you think you're right and then you're like, oh, I don't know what's going on. But don't worry, right? Let's just keep persevering, okay? So we're going to say here negative q. So we have negative q again. Then we have q squared minus 4, which is just my a in this case is 1. So you can put 1 in there if you want. And then c is pr over 2 just times by 1. Okay, that equals 0. So my q, right, is my largest. Again, this is negative, so we would want the positive version of it to get us our largest root. Okay, over 2. Now, we have to get the ratio of P to Q. I don't know, like, how anyone writes on the number of lines they actually give. Like, maybe I just write really big, I don't know. But, like, I'm always writing in this extra space. So P, we're going to say is negative Q plus Q squared minus 4PR, okay, over 2P. And this is negative Q plus Q squared minus 4PR over 2. Now, what you might see is that these are exactly the same except for the denominator. So let's just take the denominator out, right? I love that we can just do things like this in maths. It's just so wonderful. Okay, and then you'll see a very interesting thing. I hope I'm writing this correctly because I'm writing rather fast. This is the same as this. So we have 1 over P to 1. That's our ratio, which can be written as 1 to P. Okay, so something that seemed really tricky actually wasn't too bad. We just had to apply some knowledge which we had. Like, we just apply a formula, which had to be logical, identify things that look the same, do a little bit of factorization, solve for the ratio. Okay, so it wasn't too bad. As a whole, this question was really difficult, but I hope that was helpful to you in going about it. It's not perfect, right? I'm just showing you a way of going about it and helping you with some of the reasoning around it, right? I'm also learning, but I hope that this was helpful for you. Okay, cheers.